we are going to look at a workload on Snowflake called Unistore. Just think of it as like one storage place for both your hybrid tables and your analytical tables. Hybrid tables being a row store and analytical tables being the Snowflake column store that Snowflake is famous for. All right, so here we're gonna walk through what the Unistore workload is. And in the majority of the video today, we're going to look at the quick start on hybrid tables where we're actually created. And then the scripts that I actually used are in hybrid 10 and hybrid 20 right here. So we're going to walk through these scripts. And in those scripts, we're going to explore hybrid tables, prove unique and foreign key constraints, demonstrate row level locking, consistency via transaction across the hybrid and the standard table, and we're going to query joined hybrid and standard tables. And then finally, we're going to see different masks of hybrid tables based on role-based access control, and it has the same governance as the standard Snowflake table. And so the majority of the time we will be in here running these demos based on these two scripts, which you can follow along if you just copy and paste these scripts right here on Quickstart Hybrid 10 and 20. We'll put the link in the video description, or you can come to Snowflake Quickstart and search for the word hybrid, and it will be getting started with hybrid tables. So if you follow this demonstration right here, it basically shows you what hybrid tables are. You have the cloud service and query processing virtual warehouse layer that you're familiar with if you've been using Snowflake. And then there's the database storage layer. Now, in here, before hybrid tables and this Unistore workload, it was just the other Snowflake tables using Snowflake micropartitions, which is a column store. Now we have a row store called hybrid tables. And so this row store and essentially has primary keys, foreign keys, unique keys, and pretty much all the things that you're familiar with in an OLTP database. So coming back here, some more pictures. As you can see, you can create a hybrid table, primary key, foreign keys, and it tells you it's with a benefit to simplifies the architecture, slashes the operational burden, develop new features and use case faster, and ensure always on security and governance. And you basically see all this in the demo. How it works, as you can see, you can join the hybrid with the column store, and we'll show you that. And you can analyze transactional historical data very quickly, and all governed in one place. And some examples and case studies: Adobe, Northern Trust, and Siemens. Alrighty, so now if you were to follow along here, you can do this, and this is actually how I set it up. It basically shows you how to set up the worksheet, and you could just copy and paste these scripts and explore data, unique and foreign key constraints, row level locking. So I basically took this, and all credit to the Frostbite team in Snowflake who wrote this quick start, and it was very helpful. And then what I like to do is I like to run it on my own, so it's kind of like covering their demo. And then what I like to do is, basically just simplify it a little, remove some of the explanations, just run the script. So, so you could feel free to follow this on your own or follow my version. Okay, great. So now let's get to the demo itself. So created two worksheets. You could just add a worksheet by clicking here in SQL worksheet, and then you can add it. And here are the links that we just showed you. And if you want the link to this actual script, it is right here, which is this GitHub right here. Okay, and we covered what we're going to set up right here, and we're going to demo. So I'm going to run some setup script. I'll just kind of explain it at a high level. We're using a role called account admin, creating the role called Quickstart, a hybrid Quickstart role, creating a compute layer called hybrid Quickstart warehouse, granting it to this Quickstart row, creating the database called Quickstart DB, and a schema called data, and everything is belonged to this hybrid Quickstart row, which now I will use this Quickstart row. So now here I'm using this hybrid Quickstart row, and over here I'm using this hybrid Quickstart DB with the data schema. Create a file format named CSV format, and it is pointing at this stage, which is the interface to our S3 blob storage located here. And if we wanted to see what that data was, as you see, a order header and a truck CSV file. All right, set the timestamp. And then for the hybrid tables, this is now where we're going to create the hybrid tables. This will take about 20 seconds. As you can see, it's 27 seconds creating a hybrid table. That's the new type, truck ID. And so some important things, the primary key is truck ID. So you must have a truck ID, and the create table as select is the best practice. So and the reason it is the best practice is it gives you the most optimized row storage layer as you're creating it. And then look at also what it's doing. It's adding a truck email column, which is unique, and we're going to test that uniqueness. And so we're going to start querying this data very soon. So as you can see, it created it in actually 22 seconds. And by the way, we're only using the smallest compute power right here, called the extra small. All right, so very cost efficient on Snowflake, and it has an auto suspend of 60 seconds, so it'll automatically turn off after that. Okay, and then here we're going to create a standard table, and this will only take 2 seconds, just so that is kind of interesting, because you'll see that as we're pulling from this truck CSV file, it took about 20 seconds to create the truck as a hybrid table, just because the row storage takes longer to populate those objects in the Snowflake, similar to the OLTP. But when we create the column storage, since it's literally like a truck where you could just hold more things in those 16 megabyte compressed micropartitions, then it is just much faster to create as well. All right, so and as you can see here, the schema is very similar. You can create the primary key on the regular table, but it is not enforced. Same thing with the truck email. Even though we have it as unique, it is not enforced because it's using the columnar storage. And that's for speed, and that's what you see in a lot of analytical databases. Okay, so now we'll create a second one called order header right here. So let's create that one. So this is just the sample order header table, but we're going to use the traditional insert into order header way to populate, just to show you that that is possible as well. All right, so 1,000 records insert. Okay, wonderful. So now let's explore the data though. Let's explore those two tables that we just created. So we're just gonna set the context again. All right, cool. Hybrid is the penultimate column. So when we show tables like truck, what you can see here is hybrid right here. So one of them is hybrid, which is the top one, which is truck, and then truck history is that regular table. And notice with the regular tables, we get to see we always know how many rows and bytes there is in the regular table. We have that information, but we don't have that in the hybrid tables. So we likely have to use a select count star, just like we do in a regular OLTP database. And then if we show tables like order header, this one is hybrid as well, okay? So we have two hybrid tables and one regular table. So if you wanted to describe the table like truck, you could see this. So this is the hybrid table version truck. It's not truck history, it's truck. And as you can see, you can see primary keys, yes. So truck ID is the primary key, and unique key, yes. And these are enforced. And then same with the order header. This is another one that is primary key is already, and you must have a primary key. It'll require it on creation. And so, and there's no unique key, so just the primary key on the order ID. And of course, you can do show hybrid tables to see both of those tables as well. And if you wanted to just focus this on the indexes, as you can see, you want to focus on the is unique. So behind the scenes, when it creates those, when you create a primary key, it also creates the essentially index on it, which is helpful when you want to query on that data. So it tells you whether or not it is unique or not, or if it is helping you, order doing a foreign key enforcement, which this one is right here. Oh, that's okay. So now if we select star from truck, we'll see there's 450 rows. So these are all the truck records. You can see the truck email, which we created to make it unique, and also the truck ID is unique as well. Truck history, again, 450 columns. So this is essentially, we're going to show you a little bit of Snowflake, the changing dimension type 2 here, because you have the record start time and the record end time as well. And oops, if you want to see the order header, there is this version of the hybrid table right here, 1,000 records. This is a food truck business. Okay, great. So we kind of showed you how to explore data. Now let's look at proving unique and foreign key constraints work. Okay, so we have a primary key described table truck. As you can see, we kind of saw this table before. Let's intentionally cause a failure next, because what we want to do is we took the truck email and we want to insert a duplicate truck email. So this will fail. You see, duplicate value violates unique constraint and the name of the constraint, because the truck email is the same. So if we want to succeed, we essentially create a new unique email, and if the insert will work. Oops. So now we run both, and the insert will work. Excellent. So we just proved that the unique key constraint will work. Okay. So now let's do the same for the foreign key constraint. So we see the get data definition language for the order header. So the order header, right, this is the reason we created this table was to show that there's a foreign key constraint. So if we scroll down on creation, foreign key references hybrid Quickstart data database data truck ID. So this foreign key references that first table we created. So let me kind of, we'll just remember this column 264 here. Let me go back to where we created it. I forgot to highlight that. Right here. So here we're creating the hybrid table order header. And so the important things to notice where we're doing these three things: the primary key, the foreign key that references the truck ID. So this truck ID right here is a foreign key that references the truck table truck ID. And there's also a index on the order timestamp right here. So it allows us to improve queries on that. And since we didn't say unique, it is a non-unique index. Okay, so let's go back to where we left off. Right around here with the new unique email. All right, perfect. So we left off here where we were getting the data definition language, and then I went to the actual creation of that DDL. Right here, here's the foreign key. Okay, great. So now, Okay, so now we're going to create a non-existent truck ID, which is -1. So this will fail because we try to insert into an order header, but this non-existent truck ID is violating the foreign key constraint. Now, if we go use an actual truck ID, this one will succeed. So we just proved that the foreign key constraint is being enforced. So and also what we want to show is that if you truncate a table with a foreign key, a foreign key pointing to it, it will also that command will fail. Hybrid table truck cannot be truncated because it is involved in active foreign key constraints. So if we were to delete from the truck table where truck ID equal new truck ID, okay, so this will also fail because there is another table that is referencing that foreign key. But when we remove the foreign key, the record, so if we delete from order header where that order ID is this new truck ID, then now the same command, delete from truck where truck ID new truck, this will succeed. So we just proved that when you remove the foreign key record that is referring to that parent table, and you now delete the parent table, you're authorized to as well. Great, so we proved unique keys and foreign keys. So now let's move on to row level locking. So with row level locking, let's see. So we're actually going to jump between this 10 and 20 worksheet very soon here. So as you can see, there's no tables in the order header where order status is completed. So we want to take this and eventually we're going to show two records where the order status is completed. So first we get the max order ID from order header, and we're going to begin a transaction. So we're going to begin, and over here we're going to update an order header, and we're going to set the order status case completed, where we did that for the max order ID. And if we show transaction, we'll see one record. So you see my username is John right here, and it is started on here, and we're seeing a running open transaction. Now we're going to run this worksheet, Quickstart Hybrid 20, which is right here. Okay, now, so in this worksheet, we're going to set the context, and now we're going to focus on the min order ID. Okay, so now this min order ID is different from the max order ID that we're doing in Hybrid 10. And if we show transactions, we'll see the same transaction that we opened earlier. Now I'm going to update the same table where there's an open transaction on, and set order status ID and set it to order status completed for the min order ID. So now it's showing you row level locking. Even it did not lock the whole table. So now we open back the actually this is open back Quickstart Hybrid 10 worksheet and run a commit statement. So this is return to Quickstart Hybrid 10 worksheet and run a commit statement to commit the open transaction. All right, so here we are done with this one. Come back over here. So now when we commit, and we should see both records. So as you can see, the max and the min are here. And as you see, they are both completed. Remember at the beginning, they were not completed. So we showed an open transaction on this worksheet, updated the order header for the max order ID, and then came over here and did the same thing, but for the min order ID. and we proved that there is row level locking on the hybrid table, which allows for higher concurrency updates, even when you have open transaction. Of course, this is a demonstration, but when you're in real life, you want to keep these transactions as quick as possible. You do not want them to, hang around for a long time. All right, so now moving on, consistency via transaction across the hybrid and the standard table. Okay, so we're going to basically query across the hybrid and standard table. And so let me run this. So here we're going to begin transaction. So we're going to update truck, set record 2024 record start time, update truck history as well. So we update and then insert into the truck history and then commit, and I'll explain it. Okay, so in the truck history, we could see now you essentially have what is a best practice is to do the truck history in case you want to do type 2 dimensions. You could see the version prior, so you could see during this time, from the start time to end time, that truck 1 record was valid, and now this is the second version. And you could always add a is current flag as to here as well. So now you see, and then the truck table is the type 1 version of it, okay, which is the current record. So now a couple of benefits that let's slow this down. Consistency via transaction across hybrid and standard table. This is probably the best benefit, like not just doing the row store, because you could always do a kind of like OLTP row store database outside of Snowflake, but being able to have both of them co-located drives a ton of benefits in that you can just query against both of them without needing to ELT them back and forth and then govern it again and move it and maintain it and figure out which is the version of the truth. You have everything in one Snowflake, so it's very easy to do. And then also a significant amount of cost savings because you don't need ETL tools to move the data back and forth and govern it further and so on and so forth. Okay, so now we're going to query the joined hybrid and standard tables. So let's just see what tables we have in the database. There we go. We have our 3 tables again. And if we just wanted to focus on the is hybrid, we can do that using the result scan last query ID function. Okay, so the truck history is a standard table. There's 451 rows, as you can see over here. And this hybrid table right here has 1,000 rows. So now we can join hybrid and standard table without ELT tool and time. So perfect. So we're going to set an order ID here. And notice what's going on here. You're doing order header joined with truck history, and that took 197 milliseconds. So again, very fast. So you don't need to do something called like data federation. Everything is in Snowflake optimized and ready to query. And if you look at the query profile, you can see it's extremely fast to query this data. And even as you scale up the performance, I believe you'll be pleasantly surprised with the performance because you don't have to move the data back and forth. As you can see, you have a hybrid table right here, joining with this table, the truck history right here. So you're joining a hybrid table with a regular table, do a join and showing the results. Okay. And then moving on to security and governance, role-based access control is the same. So we're going to use the hybrid Quickstart. We're going to create this new row called the BI row, right? BI user rows. And we're going to give it limited power. So I can promote myself to account admin, create that row, and then assign it to my user right here. So we're going to use the power, we're going to revert back to this more powerful Quickstart row to grant the privileges to this BI user row. So notice we're granting usage on the warehouse, and I'm going to show you this in a second, where because right now I'm in the most powerful role of like account admin, or even this one, hybrid Quickstart row. Notice with this Quickstart, notice a couple of things. The compute power, when I'm using this compute power, I could change it as well. I could the drop down comes available. I could change it to a small or an extra small, or reassign it, right? But when I'm granting only the usage on this same hybrid Quickstart warehouse to this other BI row, and when we switch over there, you'll see that we will not be able to change it back and forth. Actually, this inverted triangle will be invisible. They won't have it because they will not allow. They will only allow me to use it, but I won't be able to. There's additional privileges called operate, and some other privileges, maintain or control or ownership or whatever. But I intentionally want to call that out because that's a commonly asked question. Okay, so use row hybrid Quickstart row. I'll just run it all again, and we're going to grant the privileges on what they could do. Okay, so now with this weaker row, notice it changed my row to this weaker BI user row, and now when I'm assigned this hybrid Quickstart warehouse. Now when I try to change the warehouse, notice those I cannot change it. When I float over, I cannot change it. And that's by design. So now I want to, if I try to look at this table, come back to databases over here, and I'll just hit refresh. So if I look at the data schema, I won't be able to see anything. We'll say SQL compilation order header does not exist or after, because I was granted usage on all schemas in the database, so I could see the schema. I was usage on the schema, but I was not granted select on that table. So as you can see, since this Quickstart BI row is not granted select on the tables within that schema, I do not even know that they exist when using this row. So promote to this more powerful row, grant select on it, and then when I come back down to this hybrid BI user row, and if I refresh the tables here, I will be able to now see and query them. All right, excellent. So that is the order header row. Now we're also going to show masking policy. Okay, so if I use, I'm going to go back to the powerful row, Quickstart row, create a masking policy to hide the column values. So when the current row is the powerful row, then show the column value. Otherwise, for all the rows, show masked. And you must connect to Snowflake in the context of a row. So now I'm going to apply the mask to the truck email. So alter table truck, modify the column truck email, set the masking policy to hide column values, which is this masking policy, using the truck email for the truck email column. So now I'm in the powerful row, and if I can see the truck email. So if I scroll to the right, I can see this truck email is unmasked because I'm using the powerful row. Now, when I use the weaker row, the BI row, it is all masked. So I come here, as you can see, it is using the mask that I set here. And of course, you could use regular expressions and more advanced masks if you want. Excellent. So we just proved here that the role-based access control works. It's the same role-based access control and masking that is in the standard table. So again, the benefit of Snowflake is here as well. So quick recap of everything that we just showed. we showed how to set up this demo right here. We explored the hybrid tables, used the show and describe commands. We proved the unique and foreign key constraints by deleting records in the unique and foreign key constraints, seeing the failure of those, and then successfully creating those records when they meet the constraint. We demonstrated row level locking by going between the opening a transaction in Quickstart 10 and then going to 20 and updating two rows at the same time while a transaction was open. We showed consistency via transactions across the hybrid and the standard table, and then by querying both the hybrid and the standard table. Here we showed the slowly changing dimension type 2, which is a best practice you could do, where the columnar table does the type 2 and history and bigger tables, and then the smaller table can be the OLTP, that type of architecture. And then we can join the hybrid and the standard table. And then finally, we showed the different mass of hybrid tables based on robust gas control, and the benefit is the same governance as standard tables. And if we wanted to clean up, this is the cleanup script, which I'll just run right here. All right, sweet. So that works. And then if you wanted to run it again, you could just log out, and then log back in. All right, excellent. So that concludes our demonstration of this quick start on hybrid tables. We showed the Snowflake using both the hybrid tables and the analytical tables against this quick start. Thank you.